With this session, we are going to discuss about single replacement reaction. What is single replacement reaction? As the word says, single replacements means one element can replace the another one element which present in one compound. So here, while you are performing any single replacement reaction, you require at least one compound and one element as a reactant. Like you can see here, you have one compound AB which react with one element C. And here C is one element which replace the one element present in that compound. Like here C replace A. And by replacing A, C make its own compound as CB. And A is left over there as a single element. So such kind of reaction is considered as single replacement reaction where one element able to replace another one element present in one compound. So for that, whenever the single replacement reactions happen, you need one compound and one element at least, and in which the element able to replace the another one element and form a new compound, and that element which replace is left over there. So this is considered as single replacement reaction. When, like for example, I replaced here C get replaced A and A is left over there as an element. So here we can say that element A and C that can be both are metallic in nature or non-metallic in nature. Because why I'm telling this? Because whenever any compound is formed in which we have two kinds of the ion, one is considered the cations and anions another one. So in that one, when we have a combination of positive and negative ion, so here one element if it is replaced by another one, cation can replace cation or anion can replace anion. So here AC both can be metallic or both can be non-metallic. Means both can be cation or both can be anion. Because only as I told you the cation have a ability to can replace cation only. If I said the A replace C or C replace A, means both should be metallic in nature or both should be cationic in nature or both should be anionic in nature. We are not get replaced one by another one if one both having different kind of nature, like anion cannot replace cation or cation cannot replace the anion. Only that the positive charge can replace positive charge and the negative charge can replace negative charge. So such kind of reaction is considered as single replacement reaction. Here, as I told you, you have a one compound at least and one element here. And that element which can able to replace the another one, the nature of both elements should be same. And the replacement occur on the basis of reactivity series. Means here as you see that C replace A, it means C is more reactive as compared to A. That is why C able to replace A and it's form its own compound. So this reaction is considered as single replacement reaction where you need one compound and one element, and one element replace another one on the basis of their reactivity nature, which is more reactive that can replace by another one. Okay, now as I told you, the element can replace another one. Both should be similar in nature. Both should be metallic or both should be non-metallic. If I'll say metallic, it means they are cationic, they are positive charge. And if I'll say non-metallic, it means both are anions, both having negative charge. Now I'll share with you some more examples about that cation replacement reaction or anion replacement reaction. Like you can see here, cation replacements means a single replacement reaction in which cation replace the another cation. Means one metal can replace the another metal on the basis of reactivity. So here you have aluminium and here you have a iron oxide, and that's because that aluminium is more reactive than iron. So here the aluminium have a capability to replace iron and form its own compound, that is the aluminium trioxide. Then and that iron which is replaced is left over there as an element. So you can see this kind of reaction is considered as single replacement reaction, in which one metal, one cation will replace the another cation, another metal on the basis of its reactivity nature, because here aluminium is more reactive as compared to iron. So aluminium can easily replace iron and make its own compound, and iron is left over there. So here the left hand side you have your reactant and the right hand side you have your product. Now we'll discuss about the anion replacement, means that non-metals which have negative charge. So here you have one compound and one element, in which chlorine is element and KBr, potassium bromide, is your compound. Now we are doing the replacement of anion, means non-metal replace another non-metal. So here you have a two non-metals, first is chlorine and the second one is bromide. So here the chlorine, just because chlorine is more electronegative and more reactive as compared to the bromide, so it is can easily able to replace bromide here. Now the chlorine allowed to replace bromide and get make own compound. So in product form you will get the KCl plus Br2 which left over there. So this kind of reaction is considered as anion replacement, because here anion replaces the another one anion. So this we can say that single replacement occur in the two form, mainly cation replacement and anion replacement, because you can't be mix up the charges. You can't be replace cation by anion or anion by cation. So that's why I told you the single replacement reaction is mainly represented by in two kind, cation replacement and anion replacement, where the metals can replace metals and non-metal can replace non-metals. Now I will share with you one more example about that more reactive metals with hydrogen. Because hydrogen is non-metallic nature, but it's have positive charge. Because us completely this hydrogen is mentioned in the reactivity series, because some metals are more reactive than hydrogen. So here that hydrogen is also can replace by some metals. This kind of reaction is also considered as a single replacement, because you are replacing a single element here and form a different compounds. Like you can see, I'll take zinc, which react with hydrogen chloride, which is one compound here. Now the zinc, because it's more reactive as compared to the hydrogen, so the zinc can replace hydrogen and make its own compound, and hydrogen in the form of gas is released. So here you have zinc and hydrogen chloride as a reactant. Now zinc replaces hydrogen and form zinc chloride, and hydrogen is left over there. So zinc chloride and hydrogen is our product. Now the zinc we are considered as on the basis of another reaction in which hydrogen can replace by the another element metal. Here the hydrogen can replace with the sodium. Now sodium which represented by Na, and you are taking reaction with the water molecule. Now this water molecule, because it's having hydrogen and hydrogen is on the basis of reactivity, it's less as compared to sodium. So sodium can easily replace the hydrogen here and it make its own compound as sodium hydroxide, and the hydrogen gas is released over there. So this is a kind of a single replacement reaction in which the hydrogen can be replaced by more reactive metal. Why I am discussing this kind of example? Because hydrogen is non-metallic nature, but it is having a cationic, it's have a positive charge. As I told you, the cation can replace only cation and anion can replace only anion. That's why we can consider hydrogen can replace by the metals, not by the non-metals. So there are some examples which show us how the single replacements get done, in which you need one compound or one element at least, in which the one element can allow to replace one another element which present in one compound and form its own compound, and one element get left over there. So such kind of reaction is considered as single replacement reaction. With this note we conclude the session. We'll see you in next session.